Hi everyone, and welcome to the live streaming of the Future Orchard Walks in Southern Victoria. It's great that you can join us online today. It's not quite the same as being there in person, but the good thing is that we've got the technology to be able to connect in this way, and we can still share our information and ideas. We've also got the opportunity to see some leading orchards from New Zealand without leaving the country. For those of you that don't know me, my name is Rose Daniel and I'm the Technical Manager with APAL. The theme for this round of Future Orchards is The Future is Now, and during today's Orchard Walks, you'll be hearing from Ross Wilson, who will provide a quick update on the PIPS2 projects, Dr. Nigel Schwartz from TIA, who will provide a summary on the outcomes from PIP2 fertigation research projects and present the Sonata tool, Steve Spark from AgFirst, who will explore the current and future issues, including labour, trees, quality, climate and technology, and Camilla Humphreys, the FLA for the Southern Victoria region, who will provide an update on the latest trials that she's been running. And after the presentation, Steve and Ross will take you on a virtual tour of several leading New Zealand orchards, discussing the pros and cons of different systems and demonstrating the latest critical winter tasks, including winter pruning. Before we get to our guest presenters, I quickly wanted to run through some of the activities that have been happening within APAL over the last few months. As you are probably all aware, a lot of Eastern and Southeastern Australia was affected by bushfires over the last summer, and APAL was involved in assessing the damage and preparing a submission to government to support recovery of orchards. Around 4 weeks ago, New South Wales announced that funding support for growers that were affected by bushfires, and yesterday it was announced that bushfire affected growers will also be able to apply for support to rebuild orchards from the federal government. In May, APAL staff were trained in the Emergency Plant Pest Response Deed by Plant Health Australia, and we're currently developing a standard operating procedure to ensure that the industry is better prepared in the event of an exotic plant pest entering Australia. These types of emergencies have made us more aware of the value of understanding what constitutes the apple and pear industry, and we've commenced a tree census pilot study. And that means that by understanding where orchards are located and how many trees are in those regions, we'll be more prepared to respond to emergencies in the future. There's also a lot happening in the future business space. The future business team are continuing to collect insurance-related data to understand how much businesses are paying for insurance and what type of insurance coverage is being accessed. If you'd like more information about this, please get in touch with Rochelle Zealy. Her email address you can see there at the end of point 4 on the screen. Finally, we value any feedback that you've got about the Future Orchards program. We're in the process of beginning to develop the next round of Future Orchards as this one finishes early next year. So if you've got any feedback, we'd really value that so that we can continue to make sure that we're providing relevant content and activities for you. Okay, so now without further ado, I'd like to introduce our first speaker to kick off the session. Ross Wilson, who most of you probably already know, is a founding member of AgFirst in New Zealand and brings over 30 years horticultural experience to the business. A grower in his own right, Ross has frontline experience with the issues faced by orchardists and offers his grower clients a complete consultancy service. Grower education is a passion, and Ross is a key driver of Australia's APAL's Future Orchards program. He regularly leads field days for various projects, ensuring the latest technical advances and good tree management techniques make it to the hands of growers. Over to you, Ross.
Okay, so welcome from New Zealand to this first virtual orchard walk. We don't particularly like looking at a blank screen. We'd rather be there in person, but under these extraordinary circumstances we're in, this is the next best thing. So we hope you'll learn a lot over the next hour and a half to 2 hours, and hope you enjoy the presentations and videos to come. I'm going to be very brief this morning with this presentation, just giving you a quick update of the PIPS2 R&D program, because we're very fortunate that Dr. Nigel Schwartz can present his work, which is the major update today, and he's been able to do that both for the Northern Loop and the Southern Loop. So I'm just going to update you on a few of the other programs that are going on. So just moving things around my screen. So PIPS, the PIPS2 R&D program, which is a consortium of various researchers around Australia, that program is coming to a close. But there will be a PIPS3 program, and that will be announced soon. It's too early to announce it, but watch this space. There will be a continuation of Australian researchers all around the country working collaboratively on the PIPS3 program. In the PIPS2 program, to remind you, there was the ASE, Artificial Sphere Extinction Study, done by Dr. Sally Bound, and the work that Dr. Ian Goodwin did in the Pear Laboratory up there in the Goulburn Valley. Those projects are now finished, and the results of those have been previously disseminated. The codlin moth biological control with Mastrus redens, led by Dr. David Williams in the Goulburn Valley, is ongoing, and I've got a couple of slides to give you an update of where that program's at. As I mentioned, the water and nutrient R&D, led by Nigel Swartz, is to be presented today by Nigel himself, so you get it directly from the researcher rather than via me, which makes it even better. And then there is the major study, which you'll be aware of, into biennial bearing, a big problem that we all face. And that's going to be presented, hopefully in person, if we can get in control of this damn virus, by Dario in September 2020 Orchard Walk. Page down's not working, so I've got to use the other. Just bear with me, please. Okay, so this here shows you the Mastrus that's been released throughout Australia. And you'll see there's been good releases into Victoria. What has been picked up is very good impact on codlin moth in the first year of release in all release sites. But the big unknown that the researchers are really finding quite difficult to work out is to just confirm that Mastrus has become established into the Australian ecosystem environment. And that's proving to be quite a challenge. It's proving to be quite a challenge because of various things which are quite scientific, but you can imagine to attract an insect into a site where you can measure them requires pheromones. It would appear that the lab cultured codlin moth larvae is not emitting a detectable pheromone, and the lab cultured Mastrus has got an ambiguous response to the codlin moth aggregation pheromone. A lot of scientific words in there, but fundamentally it's still a work in progress to determine whether Mastrus has become established. Dr. David Williams did say to me that based on overseas experience, particularly in California, they'd be confident that it probably has become established, and at this stage they haven't been able to prove it. This slide here, it's one that you've seen before, so I'll go over it quickly, but there's some big messages there. This is the impact of the chemistry, some of the chemistry that we're using to control pests, and its impact on, in this case, Mastrus redens, which is a biological control agent. And red is very high toxicity. So you can see there's a couple of insecticides there that basically kill the Mastrus. That's Avatar and Samurai. So you'd want to heavily restrict the application of those chemicals. It's interesting though that even some of the fungicides, you'll see the yellow band means that those fungicides are having an impact. They're not killing it, but they're having an impact on the fertility of the surviving Mastrus. So the message from this slide is I think it's important for all of our orchards going forward, and I see the challenges in Australia is you've got some nasty bugs that actually require some quite strong chemistry to control, but it's how you integrate those to create an integrated pest and disease management system on your orchards. And that requires a lot of knowledge about what the chemistry we're using has, not only in terms of controlling the pests, but also the impact on beneficial insects, of which there are a number. Another point David wanted to make you all aware, if you haven't seen it before, very good website that's been put together specifically for the Australian apple and pear pest and disease management system. So if you haven't seen this before, jump onto it, use the resources that are in there, some really good case studies and some great information on pest and disease, which is a really big factor of successful pip fruit production. Where to next? So for the IPDM program, they're trying to work out a pheromone trap to monitor mass-stress establishment. They're trying to improve the genetic diversity of the mass-stress culture. They will continue pesticide testing so that you've got good data on what pesticides are being harmful to that good guy that you see coming out of the cardboard container there. And another really good one, I think, is incorporating suitable nectar-producing plants into the orchard ecosystem that helps improve the survival of not only mass-stress, but a number of biological control agents. So that's work that's ongoing. And that's the end of my little introduction. Now I'll hand over to Nigel Swartz to go through the nutrient and water management R&D.
Good morning, everyone. Thanks very much for joining us this morning. It's a really great privilege to be able to be talking to you about some of the work that we've been doing on apples and as part of this PIPS program. So the PIPS program stands for, of course, productivity, irrigation, pests and soils. And the sort of the nutrition, irrigation side of things obviously comes under irrigation, and there's quite a big soils component to this work as well. It's certainly not all my work. This is a collaborative effort from Plant and Food Research, and there's a fellow there called Steve Green, who's the brains trust behind this model that we're going to be this decision support tool that I'll be talking to you about a bit later on. And Marcus Hardy, who many of you might have met. Actually, he's you guys are very generous and let him dig some big holes in your orchards. And Marcus is our soil physicist at TIA. And the other guy who's been working heavily on this project is B. Zheng Tan. He's a PhD student, and he's done most of the nitrogen work that I'll be presenting in a moment. And then our research supervisor, Professor Dougal Close. So moving on, what I want to be presenting to you this morning is our decision support tool, which is the primary tool developed from this project, and that's called Sonata, and it stands for Strategic Irrigation and Nitrogen Assessment Tool for Apples. Bit of a mouthful, but essentially what it is, it's a strategic tool, not a real-time tool, but a strategic tool that will guide advisors, will guide growers. I'm really hoping it guides advisors' conversations with growers on the optimization of irrigation and nitrogen application for all the apple growing regions across Australia. The focus of Sonata is really try to understand how water and nutrition, particularly nitrogen, when we're talking about nitrogen, we're talking about types, rates, timing, can be managed to satisfy tree demand and mitigate leaching and optimize fruit productivity without a cost to quality. The model requires climate and soil data, which are inputs that you'll be able to select based on where you're growing your apples. And it also requires information about the tree varieties that you're growing, the yields that you expect, and some of the other aspects of management. But to put the tool in a bit of context, this tool has been developed from the last 3 or 4 years worth of data that we've collected for the fertigation work that's been part of this PIPS program. So what we know, obviously at the moment that we're in this winter period, the trees are just about dormant, if not dormant, and you can see this little diagram on the left here. The trees have withdrawn all their nitrogen from their leaves, and the leaves have fallen off at the moment or are falling off, and they've withdrawn that nitrogen into storage organs. And that winter storage, that storage over dormancy, provides a significant portion of that first season's flush growth, that first season's growth, flowering, early fruit development and the green leaves, that early green leaf stage, so to about 4 weeks after full bloom. And we know that roots then, root uptake then occurs after about that time. And we sort of think that that's, around that mid-November point, depending on where you're growing your apples, of course. But what I really want to talk to you about this is the idea around nitrogen use efficiency. So what we know, and I've got this little chart here on top, is what we know is that there's a significant amount of nitrogen that gets removed from your crop when you harvest your fruit. Plus, the trees require nitrogen to grow, and together that makes up the nitrogen demand for the orchard. And relative to the amount of nitrogen that you apply is the equation around nitrogen use efficiency. And the reason why that's important is because we're trying to optimize that with our recommendations for nitrogen application. And obviously, we're talking about nitrogen in the context of the rest of your nutrition being right, being optimized, that your that you're still undertaking your micronutrient program, and that you've still got adequate potassium and phosphorus. And in all our research to do with nitrogen, we make sure that we're supplying commercially relevant nitrogen, phosphorus, and micronutrients with our nitrogen treatments. Now, we know that when we think about where our trees source our nitrogen from, obviously a big portion comes from the recycled, remobilized nitrogen for spring. And then there's quite a big portion, and probably an underutilized or a less well-known portion, that comes from mineralization of soil organic matter. And that organic nitrogen becomes made available to the tree. And that's probably a bigger portion than what we realize. And then the balance of that is made up by the nitrogen that we apply, whether that's a synthetic approach or whether that is a more of a sustainable approach via mulching or manuring or composting, or however you decide to manage that in your orchard rows. Then the other aspect of the work, obviously, is the irrigation component, and we know that there's a really strong interaction between nitrogen and irrigation there. And the way we have understood irrigation is use sap flow measurements to look at how much water a tree uses in various locations. So in southern Tas, we've looked at apple trees that are in their first leaf right through to third and fourth leaf when they've developed a crop, and including trees that are sort of 9 to 10 years old and are yielding 80 tonne a hectare. And we know that Ian Goodwin's provided a whole stack of data to Steve from his work, obviously in the Shepparton to Tura area, from a long history of doing sap flow work in those locations. So all this information gets included into our tool. But I want to give you a little bit more detail about what that looks like. And I've shown some of this data before in a simplified way, but we set up some fertigation trials where we wanted to essentially see what an apple tree does with nitrogen over the course of the season. So here are two charts that really show leaf nitrogen dynamics. First is the total N that's contained in the leaf lamina over the course of the season. And so here we are 4 weeks after full bloom when we start fertigating, and where we've done a full rate of about 50 units a hectare pre-harvest, and that's the green line. We've done a 50-50 rate where we've done a 25 units pre and a 25 units post-harvest. And then the orange line is a post-harvest only application. And we can really see the response from the pre-harvest only, the high rate pre-harvest only in the leaves, that nitrogen really increases. And then that sort of evens out a little bit towards sort of 15, 16 weeks after fertigation was applied. But the real interesting aspect of this is we know that the fruit came off the tree at about week 19, 20, and we can really see this spike in leaf nitrogen, which really shows and highlights the strong sink that the fruit really is for nitrogen that is applied pre-harvest. And so the question around that is, what is the implication of pre-harvest nitrogen on fruit quality? I want to talk a bit more about that in a bit. But then this chart on the right really shows you the fertilizer nitrogen component of those leaves. And so so we've applied fertilizer as a 15N, so it's a nitrogen tracer, and that allows us to track the movement of the nitrogen that we've applied through fertilizer through the tree over the course of the season. So here is the green line again, which is the full rate. We can see that there's a significant portion of the leaf which is made up of fertilizer N, and then that's decreased with the half rate nitrogen. But then the really interesting aspect to this work is what happens post-harvest. And so here we are, fruit was harvested about week 19-20, and fertigation commenced post-harvest at week 20. And we're really only seeing a really small portion of nitrogen uptake post-harvest, which makes us question the validity or the efficiency of post-harvest nitrogen. So then moving on and having a look at what the tree's nitrogen state is at dormancy. So we've excavated all these trees. We've looked at where that nitrogen is partitioned throughout the tree, and some of this data I've shown before in that November industry day at the MCG, and I just want to highlight the fact that our pre-harvest nitrogen application was used much more efficiently than the post-harvest. And we can see that by the 9.7 grams of nitrogen per tree that was recovered. And this is purely fertilizer N. And then relative to about 5.3 grams of nitrogen per tree. So that's about 50 to 60% of nitrogen that's recovered in the tree post-harvest versus pre-harvest. And and I want to draw your attention to this green portion of the pie chart here, which is the fruit, and it really identifies that 50% of that pre-harvest N makes its way into the fruit. But the other really interesting thing is that you generally assume that post-harvest N is applied so that you can build bud quality or build nitrogen reserves into storage. But our data is suggesting that actually our pre-harvest nitrogen does a very similar thing. We can actually get a significant portion of our post-harvest nitrogen storage or our winter dormancy nitrogen storage satisfied by our pre-harvest application. And in fact, it actually is not significantly different between 41% of 5.3 grams in the root versus 14.7 grams of 9.7 grams of 14.7% of 9.7 grams. So I guess what I want to show you is that this pre-harvest N is taken up so much more efficiently. And our data suggests that the fruit quality outcomes from both these forms of application are non-significantly different. We obviously are a bit concerned about softer fruit or fruit that don't color up with a pre-harvest N, but if we're applying a very limited rate and I'm advocating using a significantly less nitrogen than probably what you already do. And we know that pre-harvest N will satisfy fruit growth requirements, will satisfy tree growth and demand and storage demand requirements as well. As long as you're putting on that nitrogen, 4 weeks after full bloom in relatively frequent but small doses, I think we can get there. And then that next question then is, well, how does the tool utilize that data? And so what we've been able to do is model that leaf nitrogen content over the course of the season, and we've sort of positioned that as days after bud burst. And here are the data points, and then here is the modeled data, and we know that we can very accurately model leaf nitrogen throughout the course of the growing season. And that's exactly the same for fruit as well. From days after flowering, we can model exactly the right amount of nitrogen that needs to be in the fruit to obtain good fruit quality outcomes. These can be rescaled essentially using growing degree day function for other varieties or other locations. So then the next, obviously the really important component is the water use component. And this is the actual recorded value, which is sap flow. And so this is the amount of water that makes its way up into the tree canopy. And we can see this for a 2-year-old apple tree and a 3-year-old apple tree. And we've got all this data again for older trees as well. But what I want to show you is the fact that we can see a significant variation over the course of the season. We see that an apple tree is sort of hovering around 4 to 6 kilograms at 2 years old, 4 to 6 litres per day. And that varies based on the climate experienced on the day. So whether it's a hot, windy day versus a cool, overcast day, for example. But the red line is the model data, and that's really what I want to show, that we can actually be very certain based on the climate that the apple tree is experiencing on a day, that we can model how much water that apple tree is going to use. And again, we can do that by age as well. And here is what the tool looks like with a young tree versus a mature tree. So I just want to move on to some of the soil work that we did. And again, some of this might not be super new to you, but I want to explain to you how this data gets utilized in the tool. So you'll know that we visited some of your orchards in the Southern Vic area, and Marcus came in and they dug a great big trench, and they looked at the morphology of the soil. They took soil profiles from about 0 to a meter, and recorded what the soil looks like. Took lots of photos. At the same time, they took samples for soil chemistry, and then the critical aspect of this for this tool is the hydrology. So how much water your soil can hold, how does water move through the soil, what is the clay content, and what are all the physical factors that influence how much water that soil can hold. And then we made some recommendations about how that soil can be managed to get the most out of that soil for growth for your apple trees. And so here's just a little slide that demonstrates what the tool looks like in the background. So you won't be able to see this. All you'll be able to do is just pick a soil series, pick a soil type based on where you're growing your apples. And there will just be a pull down menu there, and the tool comes preloaded with a wide range of soils, and we've done most of the soils around the Southern Vic area. In fact, Victoria is the most well sampled location across the country, because we've got a whole stack of other data from the Victorian Soils database, and then a significant portion from our surveys too. But I highly recommend you getting onto the applesoils.com website. If, for example, we're a little bit away from where we dug the trench in a neighbour's block, for example, you can have a look at what that soil looks like, and you'll have a bit of an idea of what your soil looks like, and you can try and match that up, and that will be a good indicator on which soil type you should be selecting for the input into the tool. So the next aspect, obviously, is really critical, is the weather. We have preloaded this tool with historical data from 22 climate stations across the country. These have been downloaded from the Australian Bureau of Meteorology database. And in fact, after all these presentations that I've given across the country, we're getting lots and lots of emails with heaps more data. And that data is from weather stations on grower sites from the last 10 years, and soil moisture data from grower sites for the last 10 years. And that'll be really valuable for parameterizing the tool, for being much more location specific. So any data that you've got that you can send me on your climate is very beneficial to me. And so you'll be able to choose a particular station name. So this will be one that is as close as possible to where you're growing your apples. And we've taken ETO, air temperature, rainfall, for the harvest period for the last sort of 18 to 20 years. And again, this sheet is hidden. You won't see any of these numbers. It's a bit irrelevant to you, but it's very important to the tool. When you select a climate station, that the software loads that data into the worksheet. Okay, so what is also really important for us to understand is the impact of nitrogen and water on yield. So for us to be able to do that, we've needed to get a bit of an idea of what the expected yields are for different varieties. So this is where your orchard nets or the orchard net site's really valuable from AgFirst and also from your future orchards and focus orchards data that you've inputted into OrchardNet. So AgFirst have made this OrchardNet data available to us, and we've been able to get a bit of a handle on what the expected yields are for certain varieties at different ages. So for example, we know that this is from data across the whole country, that if you're a Granny Smith that's about 10 years old, you're hovering around that 75 to 80 to 90 tonnes a hectare. And a Pink Lady will probably start reaching maximum yield at 6 to 7 years and hover around that 70 to 80 tonnes a hectare as well. So this gives us a really good understanding about what we can expect in terms of yield data. And it also allows you to be able to see where sort of you're playing at as well relative to the rest of the country. Okay, so this is what the front end of the tool looks like, and you will be able to obviously select your apple variety, and there'll be pull down menus. And for example, here we are on the top left. Here we've selected a Gala. We've selected a Gala that's 6 years old, tree spacing 2 meters and row width 4 meters, and you'll be able to choose whether you've got a microjet irrigation infrastructure or a dripper. And you need to tell us what rate you're using, and your emitter spacing, the duration of your events, and your return period. So how many times you irrigate a day or a week, for example. And this is really important for us to be able to know how much water you're using to irrigate your apples. And then you can choose to view this as either in either millimeters or megalitres per hectare, based on how you prefer to see that. And so what this little table on the left the bottom left shows are the estimated parameters or the estimated outputs of the tool. So we're estimating that a 6-year-old Gala tree has a root depth of about 0.92 meters. We've sort of applied a drought tolerance factor, and this has given us an ability to be able to determine what your expected yields are for this age apple tree and where it's grown, etc., etc. And so it's predicting about 40 tonnes a hectare. But the other really important attribute to this is how many units of nitrogen are removed in that crop when the fruit gets removed at harvest. And so this is a really important for us to know our replacement value of nitrogen, what has to go back in to the system to replace this nitrogen that's removed. And it also tells you the amount of nitrogen that is demanded by the growing canopy over the course of the season. So these numbers here are quite important, and numbers that you can have conversations with your orchard managers or your advisors to work out, are we meeting tree demand? And then the other aspect about this is some really important data around field capacity and the refill point of your orchard. So, this will be totally related to your soil type, and this is all work that Marcus has done from soils around the country. And these are conversations that you can have with your irrigation specialist or your advisor about what your soil or the soil that you think you're growing your apples in is probably going to be looking like when it comes to your water holding ability. So then here is a bit of an output table. So you've chosen your climate zone, you've chosen your soil series, you've chosen your variety and the age of the tree, and you press the recalculate, and a couple of charts will come up, and that will show you the expected tree water use based on sap flow data over the course of the season, and it gives you some idea on how many litres a day your trees are using. And we know these are individual trees, and our model data suggesting that under this climate type that your trees could be using somewhere between 35 to 40 litres a day, which is obviously a significant amount. But it also allows us to tap into all the climate data. Tells us how much rainfall your site's expected to receive. This is the average rainfall over the last 20 years. And then how to meet your irrigation, your annual water balance with irrigation based on the calculations around ETO and ETC. And so the tool is estimating a mean irrigation requirement of about 273 millimeters. And here is another example of an output chart that you can have a conversation with your irrigator about what your root zone soil water looks like. And this is also really demonstrates to you how you can meet the irrigation requirements based on the annual water balance. So here is another final output chart that we've talked about the annual water balance and how much irrigation is required to meet that annual water balance. But what does that look like on a monthly basis? And so this chart at the top here looks at the ETO and rainfall. So this is how much rainfall you're likely to receive at your site with some error bars there, some standard deviations. over the course of the season. And then below is the red bars here, or the green bars is how much water your trees are expected to use, and then the irrigation requirements to meet that tree water use requirement. And you can see the numbers here. So I'd be really interested to see what you guys think. We've got a poll that, if Larissa could put that up now, that poll, it really helps us to try and understand how big an issue, and what you guys think, how big an issue is the cost of water for your business. And then I'd love to know whether it's a big issue, a moderate issue, or not an issue at all. But then further to that, I'd really like to know whether you guys actually have a water budget, and I'm talking about the volume of water, not necessarily the cost of water. Whether you have a water budget for your orchard, and whether you know how much water your orchard uses over the course of a season. So I mean, all this is really important for us to really know what are the issues, what are the important scenario analyses that you would actually like to assess through this tool. We really need feedback on what is important for you guys. There's some really neat opportunities to look at total nitrogen use, total water use. We obviously can't use this tool as a real-time decision support, because we don't have that immediate feedback coming from your soil moisture data and the forecasting feature of what's going to be happening in the next week or so. However, we've pitched that as part of the next PIPS program to develop that. So take this out of Excel, take this out of an Excel document and put this into a web app that is really simple to use, that takes on a bomb forecasting component, and also that also allows us to be able to input your soil moisture data as well, and then with all this other data from the previous years, give us a real-time ability to understand your tree water use and your orchard water use. So we obviously want to be able to have flexibility to adjust irrigation set points. And this is really important for us to get feedback from you about what your strategies for irrigation are. How do you like to approach irrigation over the course of the season? And how would you like to be able to manipulate when and how much water you put on? And then obviously there's some really lends itself to some opportunity for metrics. So if we know how much water costs, and if we know how much yield you're expecting, and we know where you're growing your trees, we can get a bit of an understanding of water use efficiency and a cost-benefit analysis of water. So, for example, you might be wanting to increase your yield, but that comes at a cost of extra water. We'll be able to do a cost-benefit analysis on that based on the extra water that's required to bump up that yield. So look, there's probably a lot more that I can talk about here. I really want to thank you for listening. I think there's real opportunity to sit down with Camilla down the track and any growers who are interested to pour over this Excel tool and go through it in some fine detail and show you exactly how to use it with a manual. And obviously this COVID scenario has meant that we haven't been able to do that this time, and I'm really sorry about that. I really hope that we'll be able to do that in greater detail over the next few months when we get back out of the state and travel again. But in the meantime, please feel free to get in touch with me. Very happy to have conversations with growers, with advisors about how this tool could be used, and also very keen to get hold of any data from your orchards as well. Thanks very much. Appreciate your time for listening.
Okay, thanks very much, Nigel. It looks like a great tool, and I guess a model is only as good as the data that has been used to develop it and the information that is being put in by the user. So hopefully if anyone's got any more data out there, they can share that with you. From a grower's perspective, are there any gaps in the BOM data that you've identified, and can growers add their own weather station data? And following on from that, I guess, is how essential is it that a grower might or a grower has a good leaf testing program for nitrogen monitoring?
Yeah, so I mean, there is of course always going to be gaps in the BOM data. I mean, we've only got 22 stations, and that's I guess that's supposed to be reflective of the whole country. So we're never going to pick up some of the idiosyncrasies of what a climate does on individual growers' orchards, and we do know that the way the way the land falls, the way the land lies, and different orchards, even in the same location, are going to have slightly different climate. So certainly, please, if the more specific data we've got, the better it is. At the moment, we don't have the ability to feed in real-time data from your soil moisture systems, but we certainly hope that that's going to be part of the tool in the future. Certainly, though, if people do have data, we can absolutely upload that into the tool, and then that data is then sitting there in the background of the tool. That is just like any of the other weather stations. Look, the absolute the greater opportunity there is if you do have leaf nitrogen data over the course of the season for different varieties, that's really advantageous to us as well. Ian's just mentioned there, why not access the silo database? I certainly I think that that's something that we are considering for the next stage of the tool development, Ian.
Okay. And there's just another comment from Mark here, which says the cost of water is less of a problem than availability. And I think that's becoming quite real around different apple and pear growing regions across the country.
Yeah, I'm certainly hearing that.
Okay, all right. I think we have no more questions, but we've got some poll results which we might share with you quickly. So 25% of people don't see an issue gosh, I've forgotten the poll questions. How big an issue is the cost of water for your business? So 50% of people say it's a moderate issue, 25% say it's not an issue, and 25% say it's a major issue. And obviously the access to water seems to be, for some people, becoming more and more of a problem rather than the cost. Okay. So we also asked, do you have a water budget for your business? So 60% of growers do and 40% don't. And that feeds into the third question, which, do you know how much water your orchard uses? So 82% of people do. So presumably if you have a water budget, you should know how much water your orchard is using. Any comments on that, Nigel?
Yeah, no, I mean, look, that's actually really helpful to know. And that 82% that you answered here is significantly greater than what we've seen for the rest of the country, actually. So so kudos to you guys for being really aware of how much water your orchards are using, and you can, I guess that's really evident. You know, if your water availability is a big issue, please, yeah, look, obviously you're well aware of how much water. What your water budget could look like.
Just one more question from Ian here. How do you estimate the KC before we move on to Steve, our next speaker?
Yeah, that's very much a plant and food Steve Green question, Ian. And I don't have the formulas here in front of me, but I'm trusting Steve on those calculations.
Okay. All right. Thanks very much, Nigel. We'll now move on to Steve. So Steve Spark, who will speak about the future orchard, where we are now and where we are going. So Steve is a consultant with AgFirst. He's got more than 20 years experience in pip fruit and kiwi fruit. Working with clients, he provides intensive orchard consultancies on orchard management, pruning, thinning, harvest management, and pest and disease management. His strong financial management skills also provide financial planning and monitoring, budgeting, performance analysis, and purchase appraisals for a range of clients. So I'll hand over to you, Steve.
Yep, thanks, Rose. Okay, this is a joint collaboration talk between Jonathan Brooks and myself, and covers where we've come a little bit and where we're having to head in the future. As you've been aware, in the past, Futures Orchards has highlighted a number of areas essential for achieving excellence and sustainability. And in this slides, I'm going to cover these areas here and a little bit more in the end about where we're going to end up looking at technology. So fruit quality, as you're all aware, is a bit of a mindset. We're all trying to continually improve. And we're trying to keep meeting our customers' aims. Quality does mean different things to different people, and that's what we're trying to overcome. One of the things that we're talking about there is customers, and customers have different demands. What we've learned over time is that we have to keep chasing what the customer's prepared to pay premiums for. We need to keep listening to what they are telling us and keep trying to understand exactly where the requirements are. So one of the ways New Zealand has done that, and you've all heard this before a little bit, is we've used different varieties. You guys have lots of opportunities to participate in variety clubs. And as you know, the IP that they bring are very strong. Just while I'm on that, we released in New Zealand Sun Gold, a kiwifruit variety. I might have mentioned to it in past orchard walks. This year, 700 hectares sold for $400,000 a hectare for the license right to grow 1 hectare of Sun Gold. So some of these things are gaining in huge value to growers. So that's the value of IP. Now we're also seeing a similar thing in apples, where Envy is reportedly selling for $100,000 a hectare for license. So yeah, these opportunities to be in these clubs and to get these licensed varieties can be very costly, but they can also be very lucrative as long as you're the ones with them. We're seeing a growth in club varieties and varieties per se around our country, mainly because it enables supermarkets in Europe and different areas of the UK to say they have exclusive rights to one variety that another supermarket doesn't have. So we need to keep looking at the variety mix that you've got on your orchard and understand that you're better to be in these clubs than not in them over time. So variety choice and orchard systems are critical for what we're trying to do. And we must need continual improvement. We've got plenty of regrafting going on. The variety choice is paramount, and understanding the risk rewards. Not all varieties are suited to every location. And like I said, we need to seize the opportunities as they arrive and minimize the mistakes. The other point I'll make is that the customers are always right. You need to have good knowledge of your customers. If you want to keep your customers, you need to keep supplying them with the product that they want. What we've learned from being a major exporter is that if we don't supply what the customer wants, someone else will. Climate. Interesting, a couple of days ago when we was doing this presentation, some of the growers in West Australia felt that maybe their orchards may not be in the right location for growing apples. And over time, as the climate changes, there'll be more issues for growers to try and solve in regard to, are they in the right place? There is ways we can adapt our climate, areas that we grow in with netting and different tools and that, but at the end of the day, choosing the right variety for your location and making sure you're in the right location is paramount. So climate has a lot of risks, has a lot of rewards too if you're in the right area. There are lots of models being developed now which show what different apple varieties and different trees need to function. And as we start to get more and more vagaries with the climate, we're starting to see more and more of these issues come up. So we need to develop management plans and understand how we can actually maximize the benefits and minimize the negative impacts. This is a photo of some orchards which were very common when Futures Orchard first started back 10, 12 years ago. And basically there were lots of upright branches pointing at the sky with very little fruit on. And as you remember, one of our early days push was to use string and train branches down and start getting the trees to crop. As we go forward, you'll see that the shape of orchards is going to change even more from where we are today. So existing orchards, although they're performing well for us at the moment, as wage costs and costs keep increasing, we're having to keep looking at how we can maximize yield. And as you know, the things we've been promoting is monitoring block performance through OrchardNet, make sure the orchards or the blocks are working at their potential, and look to keep upgrading or going to new varieties, at least 5 to 15% of your orchard every year. If you're not keeping up with the new varieties, you will pretty soon get left behind. We've got a major replacement program going on with Braeburn at the moment. It's had a couple of years of very poor prices, and the outlook doesn't look good, and probably as little as 10, 12 years ago, it's one of the mainstay varieties of our industry. So things do change, and you need to keep aware of what's going on. Labour and task management. This is a huge cost. It's probably 50% of most of your growing costs is involved with labour. We need to keep looking at continual improvement. And as you've been aware of Focus Orchard, we've been making simple rules. We've been looking at how we can systemize, and we're looking at how we can meet our short and long-term goals for maximum results. So having an understanding of the big picture impact on labour is going to be quite critical for an orchard in the future. People, where do you get them and how do you keep them? Previously, we've all probably been able to get by. New Zealand relies a lot on the RSE program, or importing islanders into New Zealand to help. Currently, under the COVID conditions, that's causing us a bit of concern. We had 3,000 RSEs trapped in New Zealand that couldn't get out, so we were overstocked with our pruning. So therefore, what we're trying to do now is eventually on Friday, 1,000 of them got flown home. There's still a couple of thousand left, and we're finding work for them. So one way we're using this trapped labour market, which you could call it, is we're doing more detailed winter pruning. So we're trying to do some of our fruit thinning now, because what we're not sure of is where our labour is going to come from in November, December and January for hand thinning later on in the year, but also even harvesting. We're not going to get the backpackers travelling through the country that we've seen in the past. Although we have 50,000 tourists trapped in the country, we're not necessarily going to be able to use them, and some of them might have headed home by then. There's also more and more unemployed Kiwis floating around that we'll be looking to use them to help with work and that, but it's going to pose serious questions for us. So like I said, so our challenge at the moment is to try and do more and more detailed pruning. So we're actually doing some of our fruit thinning now. One of the cheap little tools that we're using is the BCA, or the branch cross-sectional area tool, for measuring how many fruit we're going to put on a branch. And for an example like Royal Gala, we're saying, well, let's see if a branch carries 10 fruit on it. We put the BCA measure on it and work out that we're going to have to use 15 buds at 1.5 fruit per bud. So the idea there is that we can start eliminating buds, and there's a very good video which may or may not be shown today, but it's on the APAL website, which is a 2D system of hotties in Nelson that is pruning to 25 buds per metre of tree on a 2D system. It's well worth looking at that, and the detail these guys will get into both from the ground and on platforms. So short-term labour goals, we need to create plans, and what we're currently doing, like I said, is we're working out on our pruning plan, working out how much crop load we want to put on the trees, how we're going to manage our vigour, and then looking at how many fruit buds we want to put on the trees to get there. We're trying, like I said, to do some of our thinning now through better pruning detail, because we're just not sure what's around the corner as far as staff availability comes. And in the past, you've seen us promote simple pruning rules. We're still working on ways to keep those rules simple. And in most cases, we're down to 4 or 5 rules for most of the blocks that we're working with. It is interesting that the more you get into the long pruning or simple pruning rules, the easier blocks get to prune, providing each pruner is following the same rules, and getting orchard variation or row variation out is a critical component to that. So monitoring and keeping tabs on it is very important. The other thing too that is timely is the timeliness of doing these tasks. We're pruning our small fruited varieties that we're trying to get larger fruit size. We're pruning them first, and the reason is that that puts finite resources back into those buds, limited buds, which will then hopefully make those fruits slightly bigger going forward. The bigger fruiting varieties we can tend to leave last, but some of the varieties, the higher paying ones, are certainly the ones that we're putting our attention to. So we're spending our time on the varieties that are giving us the best return. Longer term solutions to do with labour, well, that's where orchard systems comes into play, better genetics and new varieties, so grafting over to the right varieties, There's robotics and harvest assist programs or machines coming in with platforms, and we're seeing quite an increase in growth in people using platforms. There's sensor development that's happening, which will help us determine the right way of doing things. And basically, we're trying to reduce waste through these newer canopies. So here we have platforms on the left here that's helping pick, and as I said, there's a video clip of platforms being used for pruning. So we're trying to get more and more out of our platforms. We've found that the old ladder system, as you've heard us in the past, comment that for picking an orchard in New Zealand, it's like climbing to base camp at Everest if you're going up and down a ladder the whole season. So that's quite a bit of extra work. And what we've noticed with platforms is that they're generally a better environment for people to work in. They're quieter, they encourage minimal movement, and the environment is so much more motivational. And you can put people on platforms that have got limited experience, may not be physically strong, they don't need to be, they don't need to cart a ladder around, they can just lean off a platform and do the job. So it's opening up our labour market a bit more to more people who can do the job, more multitasking. So Canopy Design, I suppose that's one of the areas that's very interesting coming forward. There's lots of different plans, lots of different ways. The key thing is there no one Canopy Design fits all. You can go down any canopy you want. You can have shorter canopies or taller canopies. I suppose the key thing is though is that we're looking to get some of these efficiencies. We're looking to, can we improve our total yield? We're looking for labour efficiency. Can we be more efficient? Will it lend itself to mechanisation in the future? Is it suitable for my site? If you're on hills, some of these canopies are less suitable for you. And again, in the video clip from Hoddies, they believe they're getting better fruit quality out of 2D systems in their canopies. So it's all about managing the risk and trying to get some added advantages over what you're doing. And I certainly think the trend in New Zealand is to go away from our bigger, wider space trees, more into the narrower trees, the snap trees, which are more accessible, easier to work, simpler rules, and better fruit quality longer term because there's better sunlight penetration. But preferences are in the eye of the individual, and it's whatever works for you. So there isn't one particular canopy that'll work for everybody. What I do suggest you do is pick one and stay with it, but a little bit of experimenting across the way is quite good. So technology coming forward will need to be adopted in most businesses. The key things, it needs to be commercially available, cost effective, able to create decisions or actionable outcomes, and focused on efficiency and adaptable to your orchard system. One of the things we've found with platforms, particularly if you import them from Italy, is you also need to import a container load of parts, because we've had them break down, and then if you haven't got the part on hand, it can take several weeks to get that part from another country. So making sure you've got the backup and supply of parts, and you've got the people ability to maintain the platforms and the different technology that you bring into your orchard is really quite important. And at the end, it needs to add value to your business. We've had a lot of people take platforms on and then drop them after time because they don't see them as adding value to their business. So it's a matter of looking at, are they the right choice, and can you make them work better? So where are we heading? I suppose what we see is that going forward in the future, there's going to be some changes required, as there has been changes for you guys in the last 10 or 15 years. Yes, some orchards are still the same as what they were, but you've noticed the yields have been increasing on those orchards that have adopted the change and have accepted there's new ways of doing things. Well, that trend is going to continue. So why do we need to change? Well, here's some of the issues that we see going forward. There's the health of the families and the community, social responsibility to the communities, and sustainability. All these factors are starting to drive change. Consumers are demanding that the fruit is free of residues and healthy. They're demanding that you're a good social employer and that you're not slaving staff. There's sustainability. They don't want to see waste coming in. They want to see that you can maintain and support your own business in a sustainable way going forward. Now, the focus that we see research and that taking in the future, and focus that we need to look at as growers, is are you supplying the local market or fruit selling just within Australia, or are you looking globally? If you look globally, as New Zealanders are well aware, there are a lot of demands on us for our requirements to meet minimum market standards and to meet their standards as well, both in residues, staff, well-being, and all sorts of things. And those issues are only growing more. Plastics are being banned, different packaging types, CO2 emissions. There's just all sorts of things coming, which is driving change. So we're looking to incorporate where we're trying to send our fruit. Is it local or globally? Is it integrated? We have to have integrated systems so that we can make sure it all fits together and we keep our markets happy, that we are following sustainable systems with zero waste. That's a pretty good goal, a pretty high goal for us. And how do you get zero waste? But that's where we're needing to go in the future, because they don't want to see us polluting waterways or the neighbouring rivers around our orchards. But we also must maintain our taste and nutrition, and making sure that we're giving good nutritious food of good taste. And under the COVID-19 markets at the moment, what we're seeing overseas is there's quite strong demand for high vitamin C fruit. So if you're able to grow that, and luckily apples have some of that, and some of the other fruits we grow have that as well, then the marketplace is looking satisfactory at the moment. So working on taste and nutrition. So what do we need to do to achieve this, or how are we going to achieve this? Well, we've got to keep going with implementing technology and innovation. We've got to keep looking for solutions, and we've got to learn and apply them. I suppose one of the biggest things, the lessons that I've seen in Australia, is that over the Futures Orchard program, is that when we first started, many growers weren't prepared to actually have a go at some of the ideas, some of the things we were floating around. Now that's quite common, that everyone's having a go at something interesting and something that excites them. And it's also a way of, if you're looking for new opportunities and you're learning and you're applying some of what you've learned, you'll also keep the younger members of your families involved in the orcharding and keep them excited about belonging a part. So we've got to keep learning, we keep looking for solutions. And as I've said a little bit before, but I'll reiterate it, if we don't change, if we don't look for these systems, if we don't look for sustainability and be socially minded, focusing on health, the consumers will demand that we do that. The public will demand that. If we don't do that, they will switch to someone else who is doing that. Governments are also waking up to this and making policy. We have a policy in New Zealand that by 2025, all farms, orchards have to have environmental plans. And those environmental plans must encompass water management, nutrient management, nitrogen leaching, and some other areas. So we're getting these sorts of things thrust on us now, and that's what's coming. The interesting thing is that if industry takes leadership and drives these plans earlier, what we see is that the change is more gradual and at a better pace than if it's forced on us from the consumers or from government. So just be mindful that these things are going to happen. And if you want to be orcharding in 2040 or in the future, these things will be interacting with you. So how will it all come together, and what research, what opportunities do we need to look for? Well, there are 4 key things that we've identified, that we've seen, that's being worked on with R&D around the world at the moment. Sensing technology, looking at plant health, flower and fruit numbers, ripening, soil and biology diversity, productivity, pest and diseases, all these sorts of things. And Nigel just gave a good example on watering and nutrition with the Sonata. So there's some interesting opportunities coming up for us. Data management is the other bit that's, as we get more and more computers and more information being thrown around and captured through sensors, and that it's how we manage that. Now, our group, AgFirst in New Zealand, we were testing a machine for a few years that was a crop estimation or counting tool that we drove behind a tractor, and it counted the number of fruit per tree. It's commercially available, but we were testing it for them. And the thing that struck us was that there were 3 computers in the tractor cab, and the amount of data it captured just couldn't give us anything meaningful until it went back to the lab and got processed and then sorted into a database, and then the information actually got turned into a report. We see a lot of energy going into making all the data that's being caught into timely decision models and workforce planning. So there's lots of things coming up there. And then again, automation and design. So with sensing, I'll just come back onto that. But one of the things is you're already doing, you're out walking your orchards, you're looking at your trees, you're looking at development, seeing how it's all going. But as more and more sensing comes along, this will become more automatic. And we're already using spades to dig for irrigation, or you're using irrigation monitoring systems, which is what this one on the right is. It's prints a weekly report on how much water growers should be putting on. There's different technology that we're already doing, but there's still room for more of those sorts of things. And here's an example of something that's not far away from being commercial now. A drone flies your orchard, it produces a map of your orchard and colors your trees depending on vigor. And then the program links all that information back into the root pruner, and the root pruner will go along and just root prune the vigorous trees. So we see this sort of technology being more and more common in the future and be more accessible to growers. And the benefit of that is that it can even out the orchard far quicker than someone using the hand-eye coordination. So it's all done automatically based on sound information. So we're looking forward to that. Data management, as I said, the problem is how we capture and manage all that data, and there's lots of different things going on there. So we need these decision models. We need to be able to plan with our workforce how we go about things. OrchardNet, you're already aware of, looking at yield per hectare and mapping your orchard performance or your block performance against the industry. Another one here, this one on the right, is a fruit counting app that one of my staff has developed. It's not commercially available at the moment, but it's one that we use in-house. And basically what it is, in the orchard, you can just enter your fruit numbers into your phone, and then it all gets collated into a database, and you get a nice little report of what's your average fruit per tree in that particular block. Very simple. Everyone has iPhones or these new phones now, so it's a lot easier to get these sorts of things going. And it's just a way of doing away with notebooks. Automation, I suppose that's where is probably the one that a lot of people are excited about, is looking at new picking and grading platforms. The beauty of automation, I've had one grower locally, or one pack house locally, spend just over $2 million and replace their grading tables with defect sorters. So, you know, all they're doing is spending money, capital, with better technology to actually get rid of reduced labor requirement. We just used that labor, we put more drops in the shed, so we didn't actually lose the labor, we just redistributed them to another task in the shed. So that's pretty much what we see of technology. Now the VR headsets, how do we see them in the future? Well, imagine if the staff comes onto your orchard and before they even walk out in the orchard, they put the VR headset on and they train how to thin an apple or how to prune an apple tree, all with the VR headset, all done remotely, standing in the smoko room or the yard. So these opportunities are already in other businesses now, and we see them coming into horticulture, into orcharding. The other way is, what are we using with sensors? How are we going to sense? Is it drones? Is it ATVs? Is it autonomous vehicles? All sorts of things happening there. Down on the right there is picking platforms or harvesting platforms. There's more and more activity going on in that space, certainly in New Zealand, because people are trying to get staff off the ground and into the platforms where they're more productive. And as a general rule, we're seeing between 20 and 30% increase in productivity. The other one there is automated harvesting, and there's many options here. There's also auto harvesting assist projects. And I'll just play a short video here. What's interesting with that particular machine was that it was picking the same amount of defects that other orchard staff were doing, so it was able to pick the fruit in a reasonable quality. That was the trial version of it. The aim is to put 4 or 5 arms on a machine, shrink it down a bit smaller, and let it go into the orchard. So we've talked a bit about it in the past, but that's the first video clip that's been shown of it. Very, very exciting. And there are other automated systems coming on the market that we'll see in the future. So having your orchard set up for that is going to be quite interesting to see whether you can take advantage of this sort of technology. Which leads me on to orchard design, and we're basically looking at how will the orchard design come together. And like I said, there's many different systems and they all have their uses and they're all fine. You have to get your head around them. The interesting thing about some of these systems though is they're very simple for staff to actually work in, but they're very difficult for the owners or the managers to actually work out what's best. And here are 4 different canopies that we're seeing more and more of. The V-type trellis system, the fruiting walls, whether they be 2D or V-types, the Fox orchard system from Stuart Tustin, which is this one here, which is 3.5 metre spacing, 2 metres between rows, and lots of upright leaders. In actual fact, one of the video clips we're showing today is actually a fruiting wall very similar to this, generated from an older orchard. And I'll explain some of the benefits of that. The intention in these systems here is to get higher yield, and Tustin's reportedly talking about between 140 and 160 tonne of apples and even more. It's in the experimental stage, but there's quite a bit of interest in these systems going forward. And then you have the super spindle, nice simple super spindle, prune the branch in the same as the top as you would the bottom. And these have been yielding very well too. Interesting enough, with that robotic harvester you saw before, Craig and I have been working on how to make these canopies easier for machines like that to pick most of the fruit. And even if it can pick 70 or 80% of the fruit, then that's a bonus. So future orchard canopies got to meet the future and the current needs, such as climate mitigation and risk, quality systems that the consumers want, and production and profitability, including the cost to set up, because these systems are a lot more costlier. But if you're getting the increased yield and the increased quality, then you'll see that they do stack up over time. That's an interesting photo there of a whole lot of harvest assist platforms in one orchard at one time. Probably most of us couldn't afford to put that many in there, but that's what's possible. And how to make them more efficient. And what we've seen, like I said, is quite a bit of labour efficiency from using platforms if they've been done well and the orchard is set up well for them. We've all seen the plucker tracks and the different harvest assist programs, your hail nets and canopy designs. This one in the middle here is EM mapping, electromagnetic mapping of land or orchards before you plant. And in the bottom here, you can see the red area versus the green area. So there's some differences going on in the soil type. Well, these EM mappings show whole lots of things. One can be topography. So the wet area, the red area might be where the ground is more sloping than the green area. It also can show up nutritional values in the soil. It can show up drainage issues. It can also help you better align your irrigation monitoring devices in the soil to match the soil types that you've got. When you're planting trees, you can move the trees closer or wider depending on heavy soil versus light soil. So the list sort of goes on and on as to how you can use these maps. Now, these are commercially available, and we expect to see more of them going forward in the future. You also have, again, tools like OrchardNet, where you're putting in your pruning plans, your bud thinning plans, your estimates of what you're trying to achieve, your bin targets, and then do you actually achieve them? And again, more maps looking down on the orchard from satellites, all sorts of things like that coming too. And there's even some talk that we'll be able to tell nutritional status of our orchards from satellite photos. So yeah, very exciting what's happening, but there is still a lot of work to be done. And we see that we're going to have to keep abreast of all that going forward. This is a picture of a fruiting wall here, which was an existing orchard. You can see the existing trees here. and how it's migrated fruit down. But there's a short video to follow this, which will explain this a bit more. As always, there's plenty of opportunities for us, but you just have to be willing to keep your eyes open and keep learning. And I'm sure you'll find that there'll be something in it for you as well. Thank you.
Thanks very much, Steve. You've identified a lot of decision-making points, and you've provided some really interesting examples of what's happening in New Zealand. So that's really great to see. We've got a couple of questions coming on online, which is really good. Everyone remember that there's a Q&A box at the bottom there that you can ask your questions to us. Steve, if you had a blank field, what system would you plant and why?
I would probably go the Washington V system myself. Craig likes the 2D fruiting wall, but either of those formal systems, the couple of reasons. One is the tonnage we're getting out of Washington V or the V system, to my way of thinking, for the apples, for the varieties that we're using, is very high. It's very simple to get pruning rules and staff rules. It's 25 buds per metre on a wire. It's 20 fruit per metre on the wire. And as you'll see, there's a video clip there that we won't be showing today, I don't think, but there's one there of pruning 2D. You just can't get it any simpler. So I quite like them. I do like the fruiting wall. I think, but I'd go for the V because I think it has more capacity. But the jury's still out on the fruiting wall. We're doing some interesting things with sintering and clip pruning on fruiting walls and seeing some really interesting results. So, but at this stage, yeah, the V system.
Ross, did you have a preferred system that you'd like to comment on?
If you jump onto one of the videos, you'll see my preferred system. I'm voting with my feet and my own money. So I'm going with a narrow 3-dimensional canopy. There's a picture of it right behind me, actually. That's my go-to at the moment.
There you go. Pictures speak louder than words, right? Okay, Steve, obviously the market can't sustain all of the new and emerging varieties. So what's the best strategy to minimize the risk of adopting a club variety? And could commodity varieties be a better option if done with the best strains on efficient systems?
The issue we've seen with commodity varieties, yes, there is a place for them, but what we've seen is that people, some of the supermarkets don't want the commodity variety because they want to be exclusive. So they want to offer something to their customers that another supermarket can't supply. And so therefore, we're seeing more demand on club varieties. And in reality, what we've seen is the returns are higher for the club varieties. As soon as you open the field up for everyone to grow a variety, you then come down to the lowest common denominator of quality and price, whereas the club varieties tend to control the marketing a lot more, and therefore they can maintain price. And we've got examples of that in Australia, where some of your clubs are performing a lot better than commodity varieties. So yeah, I think that's where we will be going in the future. And certainly, if you look at what's turned New Zealand around, it's been varieties and club varieties. Now, not all of them are managed properly, but yeah, you've still got to be in them.
And just to go back to the best systems, is there a preferred system if you're robotically harvesting?
I'll answer that one. I think if and when robotic harvesting becomes cost effective, the people that are on the narrow 2-dimensional systems, we will all look at them with envy. And I know there'll be some videos you don't see today, jump on and have a look, but there are growers now that are planting systems with the idea that they'll be robotically harvesting in the next 5 years. So really good point. If that's realistic for you, then you're going to be looking at these 2-dimensional canopies or very, very narrow canopies.
So Steve,
I agree with Ross. It's the narrow canopies are going to be the winners longer term that lend themselves for this technology. The technology is still in research stage at the moment, so there's still a big leap from research to commercial, but it's coming.
So just on that note of developing robotic harvesters and platforms, there's a number of research groups in Australia that are developing robotic harvesters, and some of them are out trialling those in orchards at the moment or in the last season. Is this happening in New Zealand, and is there interest in locally developed robotic harvesters compared with internationally developed systems?
I'm not sure that, certainly in apples, I'm not seeing one. I have seen one in the kiwifruit industry, but it's stalled in 6 years. It's one thing having a plan to develop one, it's another thing actually meeting that plan, because they're very complex. I think the Harvest Assist programs are having more benefit, and we're seeing more platforms from America, for argument's sake, that people are strapped into platforms and helping pick. So there's lots of there, but no, I don't know that there's too much development within New Zealand per se.
Okay. All right, thanks very much, Steve and Ross. Before we move to Camilla, I just wanted to go back to what Steve mentioned about the consumer demands and sustainability and growers taking the lead and supermarkets and that sort of thing. Hort Innovation is currently working on a sustainability story for Australian horticulture, and you can find in the Future Orchards library on the APAL website, you can find a recording of a webinar that we held a few weeks ago with Anthony Konchenko from Hort Innovation and Brent Clothier from Plant and Food New Zealand, which touches on that topic. Okay, so now I would like to introduce Camilla, who I'm sure you all know as your frontline advisor, and she's going to provide an update on the trials that she's been conducting in Southern Victoria.
I'd just like to start with one of 3 trials I conducted this last season. The topic was minimising heat stress and sunburn damage on Brookfield Gala apples to improve marketable quality of fruit in high heat stress seasons. So I'll just go to the next slide. The objective was to evaluate sunscreen and biostimulant products for their efficacy in mitigating against heat stress, minimising sunburn damage and improving fruit quality. This project follows on from some prior research undertaken at the Tatura Research Station by Dr. Ian Goodwin, who investigated the effects which evaporative cooling using overhead microsprays had on minimising heat stress on apples. So Ian Goodwin is actually with us today. So if you've got any specific questions for him, I'll leave that to the end of the presentation for some discussion, as we're just running a bit behind time and we want to get Ross on to show the videos. And also Peter Barrows, the International Business Director from Decembelo Curly, has joined us from Phoenix, Arizona. So it's really good to have him with us, and it was very fortuitous I could meet him in Australia late last year when he was out here. So as water security is a problem, this trial aimed to evaluate particle film and biostimulant products as alternatives for mitigating against heat stress and minimising sunburn. So I've got a poll, Larissa, if you could kindly put that up. I just wanted to know who of you use overhead sprinkling systems for evaporative cooling? Yes or no? I'll go on to the products now. Surround is made of calcined kaolin clay, which forms a barrier film that disperses and reflects substantial percentages of ultraviolet, visible photosynthetic active radiation and near-infrared radiation, therefore reducing the incidence of sunburn. The only negative, surround can delay the maturity of fruit for up to a week, which can impact greatly on colour. And of course, it has its residues. Megafol, a biostimulant product, comprises of a range of plant extracts from the seaweed Ascophyllum noticum. And it contains a complex of metabolites, including vitamins, amino acids, proteins, glycosides, polysaccharides and betaines, which maintain hydric conditions in the plant during periods of abiotic stress, and glycines, which are directly involved in the formation of plant tissue and chlorophyll synthesis. The final product which was evaluated is DecoShield, a calcium carbonate containing added silicon, designed to diffuse and transmit the sun's solar rays rather than absorbing it without inhibiting photosynthetic properties in the plant. So this is just electron microscope image of the calcium crystals within the leaf epidermis and mesophyll layers, which are called cystoliths. Now, the DecoShield mimics this physiological process, and in low light conditions, the cistillets help scatter light. So that's what you can see on the left-hand side. And that scatters light throughout the leaf, enabling greater efficiency and more photosynthesis to occur. So I just wanted to know also, what is your preference of particle film products, whether it's Deco Shield, Surround, or if you use anything else as a sunscreen product in your orchard. So we've got 40% using Deco Shield and 20% Surround. Thank you for that, everyone. We'll come back to that. So going to the trial, there were 3 applications over the 3-month trial period. The first application occurred when the fruit were 30 millimetres in diameter, and the harvest was on the 15th of February. Leaf surface temperature was measured using an infrared laser thermometer. As you can see back there, this is a leaf where the Surround went on, and the purple shading shows the temperature being much lower than the surrounding temperature. This was done during the field day last year at the Harcourt Orchard on the 21st of November. So it was a very hot day. As you can see on the right-hand side, it's recorded 37.8 degrees. So leaf surface temperature, the average maximum on the day of measurement in December was 25 degrees Celsius, and here the leaf surface temperature was significantly lower for the Surround treatment, 12% lower compared to the untreated control, and 6% lower than the fruit treated with the Deco Shield alone. There was no difference between the control, Deco Shield and Megafol. So fruit surface temperatures were measured using thermocouples, which were inserted beneath the fruit skin surface. And these were connected to Campbell Scientific Data Loggers donated by the Tatura Research Station. And for sunburn to be avoided, the fruit surface temperature should be below 46 degrees. So unfortunately, 2 of the data loggers were powered by old software, so did not log the data with dates, and therefore made it difficult to draw any meaningful comparisons between the treatment. But I managed to extract some data from the control and the Megafol and Deco Shield treatments. And you can see the fluctuations in temperature there across the trial period of 3 months. And it was not seen to be a significant difference there. Soil moisture was also measured using a telemetry powered weather station with soil moisture probes as an additional tool to measuring crop water availability and irrigation requirements in relation to soil properties and fluctuation in temperatures. So here there is a positive correlation in vapour pressure deficit and the air temperature. As you can see, there's spikes in mid-November and again the 9th of December and mid-December. This next graph shows the water volumetric sum of the entire 60 centimetre soil profile for the trial period. And the irrigation scheduling for the trial block was 12 litres per day. The average water requirement to keep the soil moisture at available water capacity is indicated by that green shaded area of the graph. And the average requirement to keep that water capacity is 173 millimetres per decimetre. So the irrigations of intervals of 1.5 hours per day, providing 12 litres of water to the tree, was not sufficient to sustain field capacity. As you can see, when you go into mid-December through to February, the volumetric sum drops below that green zone. So this soil moisture information is just one factor that can contribute to the trees being heat stressed during the period of the heat mitigation trials. So it's just a concept to look at. We didn't have any solar radiation sensor on the weather station, so we couldn't measure evapotranspiration rates. The next parameter which was measured was chlorophyll index. So that was measured using a SPAD meter as an objective measure of photosynthesis, and the optimal temperature for photosynthesis to occur is 25 degrees. And on this, this graph was taken from a measurement made on the 6th of January, where the average maximum temperature was 25 degrees. So the DecoShield and Megafold treated leaves measured an equivalently high chlorophyll index to the surround, with a chlorophyll index of 24 compared to DecoShield on its own, and significantly better than the untreated control. So sunburn was also measured from a total sample size of 60 fruit, 15 fruit per tree, and all treatments measured an improved level of sun protection compared to the untreated control. So you can see 8% in the untreated control and minimal in the DecoShield alone. Fruit weight was improved by 15% for the surround treatment compared to the untreated control, whilst DecoShield alone was also significantly different at 7% higher. The DecoShield and Megafold had an average fruit weight increase of 4% compared to the untreated control. Background colour was also measured on a rating scale of 1 to 4, and here you can see I've categorised all the fruit, and the colour was significantly improved for the DecoShield and Megafold treatment, with 50% of the sample of 60 fruit in the highest colour grades compared to 42% of DecoShield treated fruit, 20% of the untreated control fruit, and 2% of the surround treated fruit. Again, as I said previously, the surround can delay maturity by up to a week. As all treatments were harvested on the same date, being the 15th of February, the surround treated fruit may have been deprived physiologically a week of coloration. And you can see there, I've put them in order. The surround fruit is a fair bit lighter there, and the DecoShield treatments have a higher proportion of fruit in the 3 and 4 rating. So all up, in conclusion, the surround increased chlorophyll index by 17% and reduced leaf surface temperature by 12%, whilst DecoShield and surround can act externally on the plant to mitigate against heat stress. Biostimulant properties of Megafold has a broad spectrum activity internally within the plant. DecoShield increased fruit colour with 50% more fruit in grade 4. The low background colour of the surround treated fruit was probably due to the timing of the harvest, and fruit weight was most significantly increased for the fruit treated with surround. The surround treated fruit were 15% heavier compared to the untreated control. And both treatments, including the surround and DecoShield and Megafold, provided sunburn protection with no incidence of sun scald compared to 8% sun scald recorded for the untreated control. So I'd just like to thank a few people. Trevor Chaplin, who was the cooperator and host for the November Orchard Walk at his beautiful property in Harcourt. Dr. Ian Goodwin, research leader in crop physiology and plant production sciences from the Tatura Research Station, for his advice and provision of the data loggers And of course the suppliers, Agnova Technologies, Deco and Valagro, and Campbell Scientific for technical support, and iMetis for the setup of the weather station and soil moisture telemetry units. So thank you very much for your attention, everyone, and open to discussion. If you've got any pertinent questions on Surround, please drop a line, or anything regarding the setup of the trial in Goodwin as well.
Thanks very much, Camilla. We do have Ian and Peter online, so if anyone's got any questions for them, quickly type them in. Or if Ian and Peter, if you've got any comments, please comment away. Otherwise, we're a little pushed for time, and in the interest of not killing everybody by Zoom, we might move on to Ross now to take us to New Zealand and show us some of the leading orchards over there.
Okay, I hope we haven't cut Peter and Ian off, because they've got good information, but we can see we're running out of time. Anyway, first video that we're going to show you is Waimar Orchard in the Hawke's Bay, and then we're going back to back with a video of an orchard that Steve works with in Nelson. So look forward to your questions. We'll see you at the end of the videos. Okay, welcome everybody. We're here at Waimar Orchard with Mark Erickson, the owner of Waimar, on my right, and Warren Grant, who's the orchard manager, on my left. Welcome Warren, Mark. And we're here in a beautiful sunny Hawke's Bay day today to go through with Mark and Warren one of the blocks of jazz that's on their property, because as you'll hear later, it's a real standout. But first of all, before we get into that, Mark, can you just give us an introduction of Waimar and how the property's evolved to where it is?
Thanks, Ross. As everyone on the Northern Loop knows, I like to correct Ross every so often, so I'm going to correct him and say I'm a part owner of Waimar Fruit Company, Waimar Orchards, in conjunction with my mother and father. So yeah, my wife and I run it with my mother and father, and fourth generation on this property, so caretakers of the land. Waimar in Māori means clear white water. So we're very fortunate. We've got beautiful soils here, and Ross and I have been in partnership together for the nurturing of these crops for probably the last 15 years. So yeah, Warren, our assistant manager, he's been with us for 2 years, and he's got an abundance of knowledge with tree husbandry and a lot of technical aspects too.
This has been a stunning block in terms of its productivity and profitability now for 3 years in a row. And just to give you some idea, the jazz average in this region averages about 65 tonnes per hectare. Normally it packs out pretty well, about 80% class 1. This particular block that's behind us has been doing somewhere between 100 tonne, and this year it did 115 tonne gross per hectare. It packed out at around 85% class 1. The colour was good and the fruit size was good. So although the yield was very high, like way higher than the average, nearly double the average, the fruit quality was superb. So we just want to discuss what they think has actually contributed to this block being such a high performer. So Mark, what do you reckon it's down to?
Well, we talk about the 3 C's, so calm, consistent and canopy.
Yeah, I reckon we should go in and have a look at the trees, Mark, and have a look at what, you know, what's part of them. So let's do that. Another thing I'd like Mark and Warren to talk about is how they get down to their crop load target, because I think this is one of the fundamentals, is Waimar gets down to their optimum crop load target more quickly than a lot of other growers do, and I reckon that's putting a lot of the resources that the leaf, that the tree produces into the fruit that they want to harvest earlier on. I think that's quite significant, but you know, you want to explain how you do that, Mark. First with the chemical thinning, and then how Warren manages to get that fruit number at hand thinning. So yeah.
So yeah, Ross and I, we have these different recipes from the year before or the year before that. We just keep refining things. It's a living document effectively, and what's working for us doesn't necessarily mean it's going to work the year after, but hand in hand it's been working well for us. The girdle's actually been a real big positive and a big part of that success, because it's given us a reliable flower number and strong flowers going into the chemical thinning. So Ross and I, we come up with those recipes, we try to get the crop load down very early, so the primary sprays are very important to us. And Ross and I will come up with a figure. Sometimes I might put a little bit of extra in there as a bonus, what I call the feel-good factor. But I am quite an aggressive chemical thinner, because for my way of thinking, if you can get the crop load down as quick as you can without overdoing it, because it's all about making sure we've got our canopy full with fruit, then obviously it's going to pay us big dividends down the track.
Okay, another little advertorial here for OrchardNet. So Waimar are very good users of OrchardNet, and every year every block has a target of what they're going to farm to. And this particular block, we set a target last winter actually that we wanted to farm to about 110 tonnes per hectare of a 162 gram piece. And if you look at this tree, and perhaps Jack can sort of show you the tree, to achieve that sort of number, we needed to harvest, we thought, about 425 fruit a tree. Now, you don't always get what you thin to in a bin. There's always this pick out that we call it. But last year, Warren, as the orchard manager, had a target to thin these to, and the target was 483 fruit per tree at thinning. So you got it right, Warren. You want to just tell us what you did to actually achieve that?
Yeah, just following on from that, Ross here. Ross does very good work setting up these plans with OrchardNet for what we want to thin to. We'll do pre-counts after we put a chemical thinner through before we hand thin, and we'll get a feel for what we need to thin to on the tree. Whether what we aim for is ideally everything in singles, but that's not always possible. Having done the pre-counts, we garner some good information throughout the block. We set up a recipe of how we're going to hand thin and what number we're going to hand thin to. We'll set up very simple rules for the thinners when they come in for their hand thin, and we'll stick to those rules and monitor that very closely.
Okay, so everyone loves a pruning demonstration, so now we're going to do a pruning demonstration on these trees. Take you through what we're doing. Just to give you the fundamentals, we're actually targeting 115 tonne this coming year. We reckon on this block we need about 2.5 buds per fruit. That's where we've been the last few years, and we're happy with the vigor cropping balance that produces. So that means we're targeting about 1150 buds per tree. And we've got to leave the best 1150 buds on the tree. We've got to prune the tree so there's good light to all parts. Typically this is a 3.7 metre row spacing. We've decided that the tree cropping height wants to be no more than 4.1 metres, which Warren's got a measurement on his hydroladder. So 4.1 metres maximum height. We're aiming for 24 branches in the tree. And now Warren's going to take us through how he achieves those goals.
Yeah, we can't stress enough the importance of good, consistent pruning. So I'm just about to remove a dominating branch here in the upper part of the tree. We take our big cuts out of the tree first. I'll normally go through with a chainsaw actually throughout all the blocks and make those decision cuts. So then when we send the pruners through on ladders, they are not having to think too hard. We'll set them some very simple basic rules. There's another removal of a branch here. that's my 2 cuts up here, and now I'm ready to prune the top of this tree. We always seal our cuts with a bit of what we call Garrison. There's also a product called Back Seal, just to protect the tree against any disease. Starting at the top here, we'll leave what we call one sap drawer on the centre of the tree, and I'll remove any long upright growth first, or anything very close in to the trunk. And then I'll just follow my branch along and look for big spur clusters or wide arms which aren't required. And then I'll just move my way down the tree, follow each branch and be systematic in how you prune. Then things are not overlooked and missed. The rules that we apply for our what we call our detail pruning, we take any upright branches that are right along the plane of the branch. Anything that's laying along the top of the branch that's long and rank, we'll take. We'll try and leave side arms where we've got nice open space and light. And then on the ends, we sometimes will single the end off. When we've got competition here, we want to reduce the bud numbers. The only other rule we have in here, when we have far too many bud numbers and bud density, is we will halve up some of these bud clumps, or sometimes total removal. In this situation here, I'm just going to remove this particular clump here and halve it, instantly reducing the numbers. I might even do the same here and just halve that, just to reduce the numbers at thinning time. Yep. Here we go now. So I make my decisions on the fly as I go, and I'll follow each branch. And over the top here has to go a young branch like this. I want it to grow more, so I'm going to run it very slender. Once I've done my main cuts off here, I'm just going to double check if there's anything I've missed. So I might do a few spurs in there, a couple in there. Maybe I'll get rid of that one, I don't like that one now, and just leave that spur. That's a finished product.
Hi, I'm here with Rob Dennehy from the Pines. Rob's been working on the fruiting wall which you see behind us here. He's been converting an existing planting of raw gala on 106 rootstocks, 5x3 metre spacing, over to a fruiting wall and getting some pretty good results. So I thought we'd come and show you. We'll show you how Rob's pruning this and discuss a little bit about the detail of setting it up. This is what Rob started with, which was a big old trees, quite wide spacing. We just got so much blue sky in here that we're missing out on crop. Now we could restructure these branches and grow them out here, but that'll take some time. So the easier method we thought was, let's try and run some suckers up and make a fruiting wall and give it a go. And as it's worked out, it's actually worked out very easy, relatively cheap to do, and it's brought the crop down from these big trees closer to the ground, and it's just finding it more manageable for us, and we're getting better quality and better fruit from it. So we think it's looking pretty good. We've got a lot of vigour, and what we're finding is the fruiting wall is just dampening all this vigour out really well. So instead of having all this with this big 106 M106 rootstock interfering with the tree, it's actually now with the fruiting wall taking a lot of that sting out and making it a lot easier for us to grow the crop. The only other way we can get around this is to actually pull the block out and replant it, but that's got quite a capital cost involved. whereas this system is a lot cheaper and it's getting us a similar result. It won't get as high a yield, but it's making it better than what it was. You can see on the traditional planting is we have a lot of vigor in the tops of the trees, and these are pretty big trees. And a lot of the crop actually migrates up to the top where all that bigger wood is, and it takes a lot of work. So the intention is if we can bring it closer to the ground, turn it into more of a fruiting wall, we can get the same crop but from a lot lower tree and a lot less work and a lot easier.
Simple to set up. We just put 4 strings up, about 2 secateurs lengths apart, strung up some of our annual wood, and basically just added an extra wire, strung it right up, and just glued up the string. We then came on later and cut off our north-south branches that were getting too big, just to let some more light in here. And it was simple as that, really. And then it's just pruning twice a year.
Rob, we've got some stems here that haven't had any summer pruning. What would you do to them now?
So these stems, they're nice and strong, as you can see. So we'll come in about a secateur's length, and we just do a toilet seat cut, and we'll do that on all of the strong wood.
And what's your hope? How will that
And
from that?
What we hope to happen then is that we'll get maybe 2 shoots coming off each one. And when we come to the summertime, we'll keep the weakest one and get rid of the strongest one.
So pretty much like what's happened here, where you've got a strong shoot, so you can cut that and leave the weaker one.
Exactly.
But also you're getting some bud formation in behind it, so that strong wood is actually budding up.
Yeah, that's right.
What made you want to go towards this fruiting wall, Rob?
Well, it's simple. We got this big massive space in between the trees that's doing nothing. So we wanted something that was simple, cost effective and easy to prune and easy to pick as well, just to fill that big open space. We found that also, you know, as well as producing more fruit and better quality fruit, we've had a great side effect. It's been holding back the vigor in these trees, as you can see here, which has made pruning of the main tree quite easy, and pruning of the interstems is quite easy as well. So it's very easy to train anybody to do.
Right, thanks very much, Ross and Steve, for those videos. They're fantastic. Ross, unfortunately, has had to leave to go to another meeting. So if anyone's got any questions, please type them into the Q&A now. Steve, would you like to make any comments about the videos that we've just seen and the different orchard styles?
Yeah, everyone's got their own reasons for going to these different systems. And that's fine. So in the last video clip, there was a matter that the grower didn't want to spend a lot of money re-establishing a variety and trying to get more yield. So we just chose a simple adaptation of new technology, fruiting wall, and converted it into an existing orchard. And although it has its weaknesses, it actually was performing better than the existing planting. And it certainly got the orchard manager quite excited about it, and he's carrying on doing more and more development in that. So it was a means to solving a problem.
Ian, you're on. Welcome. Would you like to make any comments about what you've seen today, or on anything on the trials that Camilla presented, or the current videos that we've just seen? Otherwise, we will wind it up because we're really pushing for time and Zoom exposure.
Yeah, not a lot. Just you know, obviously, as we go forward, in, you know, with respect to our changes in climate, that obviously, you know, sunburn damage and the effects of stream heat events are going to increase. You know, even in the cooler regions where we grow apples, it's going to become more frequent. So, you know, we really need to start considering how we can, you know, prevent that loss in fruit quality. I think it's critical.
Yeah. Okay, and we might wind it up because we're heading towards 11 o'clock and, oh, hang on. Yay, we've got a question. So just from Mark for you, Steve. Steve, how do those branches go holding the weight of fruit on the leaders, and do they need any additional support?
Yeah, so early on there was a second wire put up high in the tree, and there was just string held up on them, and then we've tipped the top of the leaders. But no, they've held up well. As you saw, there was a pretty big crop on them. In fact, they were overcropped, and they've, being raw gala, they held up fine. So not too worried about it.
Okay, so for those of you who are interested in seeing a few more of those type of videos, AgFirst have recorded or are recording a total of 6 videos. Some of them are already up on the APAL website, and the others will be uploaded in the coming weeks. And unfortunately, that's all we've got time for today. But if you've got any other questions or topics that you'd like to discuss with the presenters today, please follow up with them directly or contact us at APAL. And I'd also like to acknowledge Hort Innovation, because this Future Orchards program is funded by the Apple and Pear Industry R&D Levy and contributions from the Australian Government, managed by Hort Innovation. And I'd also like to draw your attention to the upcoming webinars that APAL is running over the next few months. You can see a summary of those here, and you can find more information about these on the APAL website under the events tab. So if you go to the events tab, you can look through the different webinars that are coming up, and also register for those webinars. So it's a similar system to what you needed to do to register for this current Zoom session. If you've got anything that you're particularly interested in, please let us know. And in the meantime, please stay healthy, and we look forward to seeing you at one of the upcoming webinars or at the next Future Orchard Walks in September, which will hopefully be in person. Thanks very much, everyone.